Hello and welcome to a new video created by the Dark Lab. In this video I want to introduce you an open source high-level synthesis design space exploration framework that we've just released and made open source to the community. So if you go to our lab's webpage and you scroll down, you will find a link to the open source framework. You just click on GitHub, and this is the framework that we released. It comes with the precompiled binaries for Linux and for Windows, a README file that tells you how to use the framework and also the source code so you can modify it. It has been written in Qt, so it runs on Linux and Windows. Right? So you just have to download here, download the package, and it will save you to the to your computer. So in this case I'm going to use the Linux version. I've just transferred it to Linux. You can minimize this, and I will open my Linux my Linux prompt. So this is the files. So I can just open the framework, and this is the graphical user interface. So it has two main features. One is to actually analyze the exploration results. So it reads a specific file format that we cover in the README file, and I will show you quickly, briefly. So you say just load file, and here it shows you the results of an exploration. In this case, this is just finished. There's only two designs here, so it doesn't have much. You see the 1 point generated here, but you can open some other pre-generated designs, and then you can compare different methods. So let's see, for example, load file. Let's try to find some previous generated results. This one, examples come with the package, and you see here this is the trade-off curve with the Pareto optimal designs. In this case, we have created three different exploration methods: DSC, DM1, and Pro. So we have run for the same benchmark different design space exploration methods, and these are the results. And the red curve is the baseline. What it basically did is combined all the results from all the methods to create the baseline method, and it calculates typical metrics, design space exploration quality metrics like ADRS or dominance and so on, hypervolume, based on the this reference from generated by combining all three methods. So this, you can just click here to just show two of the designs or just one of the designs. You can click here to show just do not show all the optimal designs, show all the designs. You can modify what the X and the Y axis stands for, so you can do the analysis of the results here. So this is one way of using the Explorer. The other way is to actually, you can call a design space explorer within the GUI to see how the exploration results are being generated. So for that, let me go back to the previous example, previous folder. So this one here, you select a file that the Explorer will generate, and write in the same format as the GUI requires. So first, this is the file, where you can just say create a new file. Right, so this is the file that will be generated. Right, and then you can, from this text box, you can actually enter the design space explorer, which is a separate binary that you have to create separately from the GUI. You can actually copy the commands into this text window. So this basically is an explorer that we've generated. This is the binary, and these are all the input parameters that it requires, some technology libraries, some options, and then you can see run from here. And then you'll see from the console window, it's running the Explorer, and it's generating different RTL designs with different area performance trade-offs. And you see here how it populates the analysis window here, and it shows the Pareto optimal designs, and each point here is a different RTL with different unique area versus latency trade-offs in this case. So you see it's continuous exploring and tries to find the Pareto optimal design. For this particular example, is a small example that computes the average of 8 numbers, and it explores the number of functional units or the synthesis attributes in terms of pragmas and so on. So it continues. We only have one method, so you only see that, and you see here all the designs generated in a summary in terms of registers, functional units, multiplexers used, nets, latencies, and so on, reported by the high-level synthesis tool. So for every unique combination of these pragmas is generating one entry. So let's wait for it to finish. This is a small example, a few more trials, and then it should finish, and you should plot the optimal designs here, combined with all the, so this is the end of the Explorer. You see, so it generated 2 optimal designs in this case. So, and this is the result, the summary of all the designs generated. Now you can actually rerun the Explorer, and say, for example, this is iteration 2 of the same Explorer, because it's maybe a meta heuristic that depends on some random initialization or something. So you can run it again. Okay. So you can run it again. So the Explorer, and now it will populate a second Explorer trial. So this is iteration 2. So you see it has changed the color of the Explorer, and now it's generating different designs for the second Explorer. And it will go on, and you will be able to compare different runs of the same Explorer, or even completely different Explorer results. So this is the GUI. So what is the file format for this? So you see just finished here. So these are different results. So you can plot the results of the first run or the second run alone, and so on. So when you go to this Explorer window, so it will generate the file that it generates, is a data average.csv file. So this is the format required that the GUI understands. It's very simple. Here you have the method, the Explorer method. So this is the label that tells the GUI what is the Explorer. And the next one is the iteration. Is it the first, second, or third? What iteration is it? And then the attribute is just the hash value of the unique set of combination that it used. And this is the value, the result of the high-level synthesis for that particular combination of synthesis option, pragmas, and so on. So it has the area, the number of states, area of the function units, register, mux, and so on. But the most important ones are the area and the latency. This is what we have just seen in the GUI. So you can basically just annotate the area and then put all zeros here and separate by the comma, and then the latency, and the GUI will still be able to plot the area versus latency. This is the framework that we've just introduced. Feel free to download it, to modify it, to change the code, send us any comments. Please feel free to use it, and we look forward to your comments, and hopefully you'll enjoy the framework, and let us know what you think about it. Thanks very much for watching.